Welcome back to the channel. In this video, we are going to learn operators in Python. What is operators? What is the use of these operators? Operators are used to perform operations on variables or values. If you want to perform any operations, we need to use some operators. Suppose I want to perform an addition of two numbers. I need to use the operator plus. Okay. So like this, we require some operators to do some operations. Whether some arithmetic operations, assignment operations, or unary operators. You know this arithmetic operators. Okay, for adding the values, subtraction, multiplication, division. Some these are some basic operations you know everyone. Okay, and also we have assignment operators. For assigning some values, for updating the values, we are going to use this assignment operators. Unary operators. To change the sign of a value, plus to minus, minus to plus, we are going to use these unary operators. Relational or comparison operators. These are used to compare the values or whatever it is. To compare the two values or two variables, we are going to use these comparison operators. Just like greater than, less than, we are going to see this. Okay. And membership operators. Okay, these are operators we are finding that whether it's a member of it or not. We are using for by using the sequences data types, we can able to use this whether it is a present of that sequence or not. And we also have identity operators. We are checking whether the address of both variables are same or not. Okay, just like equality operators we are using, but equality operators are going to check the values whether the both values are equal or not. But whereas these identity operators checks both are sharing the same address or not. Okay, and next one is what a logical operators. This we have and or not, which we cannot able to do by using these operators. With those way operators we are going to use logical operators and or not. The result will be in the true or false manner. Okay, we'll see that. And next one is what bitwise operators. To perform operations on binary values, we are going to use this bitwise operators. Okay, let us see this in the practical way. Let's open the ideally. Yeah, let's see. I want to do some arithmetic operations. What are the arithmetic operators we have here? Place, minus, into, division, floor division, modulus, and also we have what exponential power values. So let us take some value. I'm taking some 4 plus 5. Enter. Yes, we got the addition of two numbers. The same way 10 minus some 5. Yes, we got the subtraction of this. And some 10 into some 2. Yeah, we got the multiplication of these values. 10 by 2 division 5.0. We are getting the value in the float. It's not getting in the integer, we are getting in the float. By default, it will be getting in the float. It will be in the decimal values. Okay. Suppose I don't want to get this value in the decimal format. So we have one more option to use the float division. Just what we have to do is use the double slash. That it means what? Float division. It will get the result in the integer format. Okay, no, it is not going to display in the decimal values. It is going to display in the integer format. Okay, so we also have some modulus operators, some 10 mod 2. Yeah, it displays the remainder value. Okay, suppose if the numerator is some bigger than the denominator, then what it displays? It displays the remainder value. When the numerator is bigger than the denominator, then it displays the remainder value. But whereas it is in the reverse, just like a numerator is lesser and denominator is higher. At that time, it will be displayed the result based on some formula. That's what I suppose x minus x by y, okay, into y. Based on this formula, the result is going to display here. Okay, suppose you can see here. Okay, let it be. I'm using here 2 mod 10. In the reverse I'm taking, that's it. We displayed it is what? 2. So how it's getting? 2, suppose let is the x is the 2, y is the 10. Okay, here x mod 10 we are using. Means first what is the value? X2 minus x by y is what? Some 0.5 it will come, right? And into y again. What is that y value? 10. So 0 into anything, something is 0 only. We are considering here only 0. Okay, 0 into something 0. So it is a 0 complete. So what the value remains? 2. That's why we are getting this 2. Okay, clear about it. And also we have exponential values also. Suppose I want to use this 2 double asterisk 3, means it is represented as a 2 power 3. That's it. 8. So these are some arithmetic operations. Clear about it? Right. Next, and next one is what assignment operators. Same, these assignment operators are used to assign the values and to update the values. We are using these assignment operators. For example, I am taking that some a equals to some 10. Okay, you are using your equal to operator to assign a value. We have assignment operators, so plus equals to, minus equals to, division equals to, all same arithmetic operators. It is going to add with the equal to symbol. Alright. So what I'm doing, a plus equals to 2. So what will be the answer if I print a? I got the 12 answer. How? How means it is going to expand. A plus equals to 2 means nothing but a equals to a plus 2. That's it. What is the a value? 10 plus 2. What is the value of that a 10 plus 2? 12. So that is going to store here 12. Okay, a equals to 10 plus 2, that is 12. So that is what we get here result. Same way, if I use like this, a minus 2, what is the value I can able to get? Now, a value is what? 12. 12 minus 2 is what? You get as a 10, right? So let us print a. Like this, we are going to update the values. In the similar way, we are going to use just like a into equals to some 2. Then what will be the output? What is the a value? 10. 10 into 2. It is going to update here. 20. Like this, we are going to update the values by using these assignment operators. Clear about it? Right. Next, we have unary operators also, right? What is this unary operators will do? We have plus and minus in this. Suppose to change the signs, we are using these unary operators. Suppose I'm taking here n equals to 2. Okay. If I print n, I'll get 2. If I want to change the sign of this, just I'm using minus n, to print minus 2, plus n, to print plus 2, right? So to change the sign of the values, we can able to use these unary operators, plus and minus. Okay, clear about it? Okay, next, to compare the values, we are going to use what? Comparison operators, right? Suppose n equals to some 5 and some z equals to some 8. Let us see, n is greater than z. Is true or false? False. Okay. Suppose n is less than z. True. N is greater than or equals to z. False. Okay, means here it is going to check here whether that is greater. If it is not true, then it's going to check here equal to symbol, whether it's equal or not. If both are not satisfying, then it will display as a false. If any of these is satisfying, display as true. Okay, like this we are going to check this comparing these values. And if you want to compare like this, you can compare. Suppose n is greater than 5, false. Okay, you can directly use the values as well. Suppose 3 is equals to 5, false. Okay, suppose n1 equals to some 4 and n2 is equals to some 4. Okay, now I'm checking n1 is equal to n2. It is true, right? Yeah. Now n1 is not equal to n2. It's false. If we are using exclamatory symbol and equal to means it is not equal to. You are checking that whether it is not equal or not. Okay, if both are not equal, then it will be the true. Suppose 2 not equal to 5. Yes, true, because it is both are different values. Like this, we can able to compare the values by using these relational or comparational operators. Clear? Okay, let us see membership operators. Suppose I'm taking here S1 equals to, in the list I'm taking some 1, 2, some 102, some 45 and some 35. So these are some list of values I took here. I want to check some value whether 2 is present in that list or not. Okay, so 2 in S1. If it is present, it returns true. Suppose 100 in S1. False, because 100 is not present in that list. Okay, suppose 100 not in S1. Yes, it's true. It's not 100 is not there in the S1. Suppose I'm assigning here n equals to 5. N is n in S1. Yes, it's also false. N is not there in this one. Suppose some x equals to 45. X in S1. Yes, x is there in the S1. 45. So like this, we can able to use this in and not in operators. It is known as what a membership operators for checking whether it is present in the sequence or not. Okay, clear about it. Next, we'll see about the identity operators. Okay, what is this identity operators? In this, we have is and is not. What is the use of this is and is not identity operators means? Just like a equality operator, we are checking that both values are equal or not. Same here, we are checking that both value addresses where they are storing, whether they are sharing this equal address or not. Suppose n1 equals to 5, n2 equals to same 5 I am using here. N1 and n2 both are different variables, but here 5 and 5 both values are same. If both values are same, then they share the same memory, right? So here we are checking n1 is n2. Yes, it's true. Okay, same here, n1 is not n2. Yes, it's both because both are same, so it is false. Okay, right. Okay, we have these logical operators and or not, right? For these things and bitwise operators also, bitwise and bitwise or bitwise XOR, left shift and right shift we have here, right? So for these things we have to know something. Okay, let's see what is that. Suppose this is the AND operations. Some x and y are the inputs and c will be the final result. If x is what 0 and y is 0, then the result of c is also 0. Here 0 and 1s are nothing but true and false. 0 is what? False, 1 is what? True. Okay. If both inputs are false, the output is also false if you are using AND operation. Okay. If both conditions are true, then only the result will be true here. Okay. If any one condition is true and one condition is false, still it is a false. Okay. If both conditions are true, then only the result will be true. Otherwise, it will be the false. Otherwise, it will be the false. That is what AND operation. You can use this thing results for this bitwise AND also. This is a bitwise AND symbol. Okay, you can see here. Note true is 1 and false is 0. And also we have R. Okay, what about this R? Same here. 0 and 0. 0 or 0 is 0 only. Means False or false? False only. One is false and one is true, then the result will be true. One is true and another one is false, then also result will be true. If both are true, result will be true. Any one of them is true, result will be true. If both are false, then only the result will be false. If any one of the input is true, the result is also going to be true. This is a symbol of bitwise OR. Okay. Now in the same way, let's see not. Logical operation not. If the input is 0, output is 1. The output, if the input is 1, output is 0. Reverse. Okay, this is about not. And also know about these XOR also is used in the bitwise operators. Okay, the cap symbol will be used here. If both inputs are 0 and 0, the result will be 0. If both inputs are true and true, then also the result is 0 only. If either any one is true, then only the result will be true. If both are true also false, both are false also false. If any one of them is true, then only the result will be true. That is what XOR. Clear about it? So let us try to implement this logical operations. Okay. Okay, let us see some logical operations. Let us take here n1 equals to some 4 and n2 equals to some 5. Okay. N1 is greater than n2 and n2 is greater than n1. Okay, what is the result for this? False. Why? N1 is greater than n2? No, here n2 is the greatest, not n1. Okay, and here n2 is greater than n1. Yes, this is true, but this is false. False and true is what? False only. Okay, same way, let us see n1 is greater than n2, or I am using or n2 is greater than n1. Now it is true because one thing is true, the result will be true only if you are using or. Okay, here this condition is false, but this condition is true, so we got the result true only. Okay, for example, not of n1 is greater than n2. Actually n1 is greater than n2 is false, but here we are using not operation, means we'll get a true. Reverse. True means false, false means true. Like this we can able to do this what logical operations. Clear about it? Let us see about this bitwise operators. We are using these bitwise operators to perform operations on binary values. Okay, let us see here n1 equals to some 2 I am taking, and let us say n2 equals to okay some 3 I am taking. Okay, I need to perform a bitwise AND operation on this n1 and n2. Let is 2 and 3. To do binary operation on 2 and 3, we need to convert this 2 and 3 into binary values, right? So what will be the result of this 2 binary form? We have to do with the LCM. 2 ones are 2, nothing left, keep it 0. So just write a 4-bit values, so bottom to up. So 0, 0, 1, 0 is the value of 2. Similar way, let us do with the 3 also. So 3, okay, 2 ones are 2, 1 is left here. So 1 and 1. Okay, what will be 0, 0, 1 and 1. So this is a value of 3, this is a value of 2 in the binary values. Okay, now for these binary values we need to perform AND operation. Okay, 0 and 1, 0, 1 and 1, 1, 0 and 0, 0, 0 and 0, 0. So what is the output we got here? 0, 0, 1, 0. 0, 0, 1, 0 is what? Same 2. 2 is the output for 2 and 3. 2 is the output for 2 and 3. Similarly, if you are doing with a 2 or 3, what will be the output? So 0, 0, 1, 0 is the 2 and 0, 0, 1, 1 is the 3 in the binary form. Now we need to perform the OR operation here. So what will be the output for this? 0 or 1? 1, 1 or 1? 1, 0 or 0? 0, 0 or 0? 0. So what is the result of this? 3. This is what? 3. 3 is the result of 2 or 3. Clear about it. Like this we can able to do. We are performing the operations on binary values. That's what this is a bitwise operators means. Okay. So same way we can do with the XOR also. Okay. And also, what is this, a left shift and right shift? Left shift and a right shift means nothing but we are shifting the values. How many values you want to shift? Suppose from 2 I want to shift one value. Okay, let us see. Left shift and right shift same. Okay. Suppose 0, 0, 1, 0. 0, 1, 0 is what? 2 value. 2 is left shift, 1 means one value we have to shift to the left side. Okay, it's a value, how many values to shift to the left side. Okay, from the left side, just shift to the right side. So it will become what? 0, 1, 0 and 0. Okay, like this we can able to use this. Okay, what is the value of it? So let us see, 2 power 0, 2 power 1 and 2 power 2, 2 power 3. So something into 0, 0 only. So 2 power 0, 0, 2 power 1, 0, 2 power 2. We have here 1. So that's why I'm taking here 2 power 2 is what? 4. 4 is our output if you are shifting here 2 left shift 1. Okay. Whereas same here right shift means suppose 0, 0, 1, 0. So right shift, just shift this side. From right side shift to the left side. So what is the output here? 0, 0, 0 and 1. So what is that? 1 is the output for to right shift left, to right shift 1. This is what? 4 is the output for this. Like this we are going to use binary values, performing operations on binary values. That is what bitwise operators. Practically we are not going to use that much of bitwise operators. We will continue. Okay, in the next sessions we will going to see about some other things. Okay, until that keep learning, like, share, subscribe. Okay, మీ ఫ్రెండ్స్ ఎవరైనా పైథాన్ నేర్చుకోవాలనుకుంటే షేర్ చేసేయండి. Okay, see you again. Bye bye. Happy learning.